In a triangle ABC, the internal bisectors of B and C meet at O. Prove that OA is the internal bisector of A. In a triangle ABC, B meets at O, it bisects this angle. C meets at O and bisects. We need to prove that OA is the internal bisector of A. Given ABC in which OB, OC or the bisectors of B and C respectively, we need to prove OA bisects A. We draw OD perpendicular to BC, OE perpendicular to CA and OF perpendicular to AB. Let us take these two triangles ODC and OEC. In this, because CO bisects this angle C, then this angle is equal to this angle. Because we have drawn the perpendiculars OD and OE, the angle D, that is ODC, is equal to OE. This angle and this angle of these two triangles are equal. This angle and this angle of these two triangles are equal. And OC is a common side for both the triangles. We know that when the two angles and one side of one triangle is equal to the two angles and one side of the other triangle, then those two triangles are congruent. Therefore, OD is equal to OE. Corresponding parts of congruent triangles. OD is equal to OE. So in these two triangles, these two angles are equal because this was bisecting this angle, and these two are equal because they are 90 degrees, and OCN is same for both the triangles. Therefore, according to CPCT, then OD is equal to OE. Similarly, in these two triangles of ODB and OFB, these two are similar because BOB is bisecting this B angle. This angle is equal to this angle. This angle is equal to this angle because we have drawn perpendiculars, and this OB is common for both the triangles. Then ODB is congruent to OFB. So this OD is equal to OF. OD is equal to OF because of CPCT. So from 1 and 2, because OD is equal to OF, OD is equal to OE, we get OE is equal to OF. OE is equal to OF. OE is equal to OF. And OA is equal to AO. We are taking these two triangles now. AOF and AOE. OE is equal to OF from 1 and 2, and this is 90 degrees and this is 90 degrees. AFO and this is equal, and AO is a common this thing. That means two sides here, this side is equal to this side and this side is equal to this side. SSA, that means SSA axiom we are using here. So these two sides are equal and one angle is equal. See here, this angle is equal to this angle, that is equal to 90 degree. This side is same for both the things, and OF is equal to OE. From this we come to know triangle OEA is congruent to triangle OFA. RHS axiom. One right angle, in a right angle triangle, hypotenuse and the side, one side when equal, then those two triangles are congruent. Because these two triangles are congruent, this angle is equal to this angle. Angle OAE is equal to OAF, corresponding parts of congruent triangles. OAF is equal to OAE. That means that is equal to OA bisects A. When these two are equal, that means when these two angles are equal, that means AO is bisecting that angle. That gives, that is the proof that they have asked us to prove, then we have proved. In this summary, prove these two are congruent. Once these two are congruent, then this is equal to this OD is equal to OE, then prove these two are congruent, then this is equal to this. Once this is equal to this and this is equal to this, then this side will become equal to this. So when hypotenuse and one side, one angle is same for the things, then this triangle is equal to this triangle. These two are congruent. Once these two are congruent, then this angle and this angle are equal. Once this and this angle are same, then we can say that OA is bisecting the angle A. Like this, you have to analyze visually, then you should start writing. So you should not get confused. So may prove this angle, this triangle congruent, then this triangle congruent. Because these two are congruent, this and this is equal to this and this. Because this is equal to both of this, then this will be equal to this. And prove that these two are congruent. Once you prove these two are congruent, then we can always say that OA bisects the triangle A.